Hello, everybody. I'm Ludger Jansen, and I'm very excited to be able to present you our ideas on integrating operational definitions for healthspan and aging. In this presentation, I want to present you 5 ideas stemming from our paper on health and aging, unifying concepts that has been published this year. And in this talk, I want to start from some truisms about scientific concepts. Scientific concepts often start as vague, promising, intuitive ideas. And what then happens is that scientists all around the world search for methods of measurements and apply them. And they come up with explicit definitions. And well, of course, for all these methods of measurements, you can ask whether they are objective and reliable, whether they all measure what they are meant to measure, whether they are valid, and, well, whether they all measure the same thing. And if you look at the definitions suggested in the literature for virtually any phenomena, you find definitions that widely differ in meaning and that may seem to define totally different things, though they all may stem from the very same intuitive idea. So, why do we need precise definitions in science at all? Well, we want to make our vague ideas precise. We want to make our implicit assumptions explicit, and we want to connect our ideas with methods of measurement. And so, definitions in science should, well, capture that original vague idea. They should be adequate. They should be clear and unambiguous. They should connect to methods of measurements. They should be operationalizable. They should avoid arbitrary boundaries, and in biology, so general concepts like health and age should be applicable across species. So we start from an obvious phenomenon. Organisms age. Well, most organisms age. We start from an intuitive idea. Well, not all organisms of the same species die at the same chronological age. They seem to be in a different state of uh, their body that sustains their health and survival more or less. So they may have a different biological age. And, well, we can try to apply this idea for two different goals. We may want to extend our lifespan, or we want to extend our health span. Now, having two goals is a problem because it might not be possible to maximize both goals at the same time. They might be in competition, they might be incompatible. And which one is more important is matter of a subjective decision. For this reason, we suggest to aggregate these two goals. We define the term of art well-being as the weighted sum of health and survival, and we can then define biological aging as a process that reduces well-being. Well, health is a difficult term in itself. Health is gradual and vague. It's a multi-level phenomenon. We have healthy cells, organs, organisms, It's a cross-species phenomenon. We have healthy plants and healthy humans. And there's a huge debate in philosophy on its proper definition. Well, I will spare you that discussion and come up with our second idea. So, our second idea is to have a very formal framework to start with for health. We define health as the absence of dysfunction and disease. And then later, in the operationalization, fill this with meat. That allows us to, well, straight away define health span as the period of time an organism is healthy. We assume that health might be regained, as so the health span might be discontinuous. It doesn't need to be. But there's another problem, the problem of arbitrary boundaries. In medicine, in biology in general, well, the world is continuous and gradual, and there are rarely sharp boundaries. So, how do we distinguish healthy states from non-healthy states? Well, we could, well, arbitrarily set, well, some values to limit healthy states, but we would like to avoid this kind of arbitrariness. Instead, we want to use reference groups here as a means for benchmarking our health data through comparison with the average in these reference groups. That introduces a relative element into our conceptual framework, but it does avoid arbitrary boundaries. Our fourth idea addresses the need to connect definitions in empirical sciences, at least, with data. Yeah, for example, for human, we could use WHO standards in order to define what lack of dysfunction and lack of disease is. We could refer the ICF, the International Classification of Function, Disability and Health, or the ICD for diseases, the International Classification of Diseases. But that immediately gives rise to the next problem, the problem of the many operationalizations. In our paper, we collected operationalizations for Healthspan from a wide range of papers. And as you see here in our table, there is a lot of them. So we need another idea to integrate all these predictors. And we do that by coming up with an ontology of aging predictors with a hierarchy, the hierarchy of aging predictors that allows us to integrate different data from different sources and to avoid double counting. Now it's time for thought experiment, the Star Trek medicine thought experiment. Suppose you can totally scan the present state of an organism. Suppose you have all the data you may wish of an individual. So, what can you do with that? Can you infer the past? Can you answer the question, when did the life of this organism begin? Yes. You can make an educated guess about the chronological age if you know something about the size of the bones, or if you know about epigenetic clocks. But that is not the only way we can use these data. In fact, in modern industrialized societies, we most often know our chronological age, so these methods are normally used in forensic context only. But we can use the data to ask questions about the future. What are the prospects for this organism? What is its life expectancy, its health expectancy, or aggregate these two, what is its future well being? And if you ask these questions, you ask questions about its biological age. So, how can we get the biological age conceptually? Now, we define a biomarker as any feature of the state of an individual that allows prediction of another feature of the same individual, be it in the past, present, or future. And we define a biomarker of aging as any feature of an individual that predicts a temporarily later feature of ill being or well being better than chronological age. And we see biological age as the composite biomarker that predicts the future well being of an individual in the best possible way. Seen this way, biological age is not a number, but it's a complex quality of an organism. All actual measurements will always rest on a finite set of data, will only always use a finite set of biomarkers, and they will always be estimates of biological age only that could be improved by using more data or more biomarkers. Thank you very much.